Hello, Math 2 students. We are on the second lesson of week 2.5. This is another way to write quadratic equations, which, of course, make parabola. And we're also going to talk about transformation. So we're talking about vertex form, which is another way to write it. We've been writing in standard form, and the transformations. And if you remember way back at the beginning of the semester, we talked some about transformations. We did dilations and translations where they moved. And this is really just kind of a continuation of that, the transformation. So let's go ahead and get started. You have your notes in front of you, and my notes will be exactly like yours. So you're just going to write what I write. Okay, so vertex form again is just another way to write a quadratic equation or a quadratic function. If you remember, what we've been doing is standard form, and make this, there we go. Standard form looks like this: a times x squared plus b times x plus c. So we've been doing that where, we can use this in quadratic formula. We have an a value, a b value, a c value. Vertex form looks like this right here. And so we have the a value is the same as the a value up here. We have an x minus h, which this is one of the transformations, okay? And then that whole thing is squared. And then we have a plus k out here. Plus k and plus c are actually the same thing. It's just written in a different way. And on this, the vertex is actually h and k. Now let me show you, because we have an x minus h here, it's a little bit tricky, but it's not too bad. So let me just give you like a real world example. So let's say we had y equals, let's do 2 times x plus 4 minus 2. And we were asked to write the vertex. So this is in vertex form. Now, because it's x minus h, x plus 4 is x minus negative 4. So the vertex would be negative 4 and negative 2. Now, the only thing you really need to remember is that whatever this number in parentheses is right here, I'm sorry, I should have put a squared up there. Whatever that number is in parentheses, we're going to take the opposite of it, okay? Because it's x minus h, and the vertex, the x value is h. So we're just going to take the opposite of that number. So the vertex is negative 4, and then this number right here, we're going to just take whatever that number is, negative 2. All right, so the vertex of that parabola would be at negative 4, negative 2. So that's really easy. Remember, yesterday we were finding the vertex by a formula. We were doing the opposite of b over 2a. Well, you don't have to do that if you have it in vertex form already. You just look at the number that's in parentheses, take the opposite of it, and then the number that's outside the parentheses. And if there's not a number outside the parentheses, then it's just plus 0. And then those are the coordinates of the vertex. Okay, so when we're talking about transformations, a couple things. One thing we look at is the a value right here. And I want to take you over to Desmos and show you something. Okay, so you don't have to go to Desmos. I just want you to look at this. So what I did was I typed in over here on this top line, I typed in the vertex form with the h and the k exactly like they would be in our vertex form. So I added what we call a slider for a, h, and k. So if a is 1, h is 0, and k is 0, that means the vertex is at 0, 0. And this is what we call our parent function, okay? So as I move h, let's just move h first. So if I move h to the left, you see how my h is a negative 1. Okay, so if h is a negative 1 up here, that would read x plus 1. So as I make my h move like negative 1, okay, so negative 2, it's going to move further to the left. X minus negative 2 would read up here in parentheses x plus 2. So what it looks like is it looks like it's moving in the opposite direction. Let me bring this back to a 0. And then if I move it, make it move to the right, You see, as I make h greater, it moves more to the right. Okay, but if h is 2, this is going to say x minus 2. So if you have like minus 2 up here, it's moving to the right. So that is my left and right movement. H controls the left and right movement. Let me take it back to 0. Let's look at the k. Let's see what it does. So as I make k go into the negatives, the vertex is moving in a downward direction. And as I move it to the positive, the vertex moves in a positive direction. You see, if k is positive 2, the vertex is at positive 2 on the y-axis. Okay, so the thing that I really wanted to show you, I'm going to move this back to 0 again. Again, this is what we call the parent function. This is where the vertex is at 0, 0, and it looks normal. Like this part is a normal parabola. Okay, so let's look at a. If a is 1, then this is the parent function. Okay, if I start to make a bigger, look and see what happens. That is called a vertical stretch. I want you to imagine that you were pulling this parabola from the top and the bottom. It would become skinnier, and that's kind of what I think about. So as I go bigger, it becomes skinnier. All right, now let's go back to 1. Okay, there's the parent function. If I go between 1 and 0, or 0 and 1, so that's 0.7, 0.6, 0.5, 0.4, it gets what I like to look at it as fatter. It gets fatter. That is what we call a vertical compression. In other words, like imagine you have a marshmallow, okay, like a big marshmallow, and you squeeze it top and bottom. It's going to kind of spread out. The sides of it are going to kind of spread out, kind of like this parabola is doing as I keep moving it. Okay, now when I go into the negative, what happens is it's reflected. So that, remember we did reflections earlier this semester. It reflects across that x-axis. And then it keeps getting skinnier and skinnier and skinnier. As I move it this way, it gets wider. So that's kind of what we're going to think of, skinnier and wider. I think of fat, I say fatter. But, and if, look, if a is 0, a can't be 0 and it be a parabola. So a will never be 0. It's always going to be greater than 1 or less, greater than 0 or less than 0. Okay, let's go back to our notes. So let's talk about that a value again. The effect of a. Okay, so a is either a stretch. Whoops, I don't have my pen. It's either what we call a stretch or a compression. I'm just going to abbreviate that. Okay, if a is larger than 1, if you remember on our graph that we were just looking at on Desmos, when a is greater than 1, what happens is it is a vertical stretch. That's what we call it. You might as well get used to these terms because we use this a lot in Math 3 as well. In other words, it gets skinnier. And what we're talking about is what happens to that parent function when a is greater than 1. If a is a fraction or a decimal, if you remember, when a was between 0 and 1, and it will never be 0, so we're going to put less than. If a is between 0 and 1, what happens is a vertical, what we call a vertical compression. My pen's acting up tonight. And basically, I think of that as being fatter or wider. I know fatter is a mean word, but it looks fatter to me. And then if a is negative, that is a reflection over the x-axis. Okay, let's look at these functions down here. Look at just the a value. Let me see if I can grab a highlighter. So this a value is -2, 1/3, 4, and then that's 0.2. Now let's think about what 0.2 means. 0.2 is a fraction. Most of the time you can just look at the a, and if it's a fraction, then you know it's fatter. 0.2 is the same as 1/5. So this a value is 1/5. So if we were talking about the skinniest to the widest, or the narrowest to the widest, we would look at what's the biggest number here. What's the biggest a value we have? Well, 4 is the biggest. So this would be like number 1 in narrowest to widest, okay? And then the next one after that would be this -2. Now, even though it's a negative, that means it would point it would open down, but it's still, this would be the second widest, or the second skinniest. And then 1/3 is bigger than 1/5. So this would be the third one, and then this would be the fattest one. So this one might look something like this, where the 1/3 might be a little bit fatter, but not quite as fat as that one. And then this one with the 2 might look like that. And then the 4 would be like really skinny, like that. Okay, so in vertex form, the effect of the H term, and you remember it's y equals A times, and then you've got an X minus H in parentheses, and then that's your squared, plus K. So this H term right here, the effect of that, this is the left and right movement. So it's that translation left or right. I want you to mark this part out. And I just want you to understand that if the number in parentheses is a negative number, in other words, if it looks like this, x minus 3, that is a movement to the right. So it's opposite of what we think. Because a negative, usually you think, oh, that's left. Negative is left on the number line. But it's opposite because of that minus right there. So if it's x minus 3, it's x minus positive 3. Anyway, it moves right 3, okay? If it's a positive number, such as x plus 3, then that is a left movement. So left 3. The effect of K, this is the up and down movement. If it is subtracted, in other words, if it's negative, that's down. So the K part, it's exactly what it looks like. The H part, you take the opposite of the number. If K is added, if it's positive, that is an upward movement. Okay, so let's look at some actual transformations. The next part of your notes has some actual equations here, some actual functions. And let's look at, the first thing I like to find is the vertex, because that actually tells me left and right, up and down. So that's kind of what I like to look at first. So let's look at C. Let's look at this one first. Okay, so first thing I want to do is the vertex. That tells me left and right, up and down, and it's easier that way in my opinion. The vertex is going to be the opposite of this number, -3. And then it's going to be this number right here, 4. So if you just look at the vertex, this is what I would call literal. In other words, the first one here, oh, and I put that on the wrong line, I'm sorry. -3, 4. There we go. Okay, so if I look at these two numbers in the vertex instead of looking over here, well, -3 tells me it moves left 3. And if I look at the +3, remember it's the opposite. So left 3, and then the +4, up 4. Is the A value, is there something right here that's other than 1? No, so that there's no stretch or compression or anything. So that's the transformation that this graph would take. So from the parent function, the vertex would be from 0, left 3, and up 4. Okay, let's go up here to A. This one looks a little bit different. I could also write this one like this. So if you don't see those parentheses, that's x plus 0. All right, so what is the vertex here? The vertex is 0, 5. All right, so that's no left and right movement, but it's 5 up. So it moves up 5 from that parent function. So let's go back over to Desmos real quick. And so on that last one, my vertex was at 0, 5. All right, so, and K was 5. Oh, let me make A 1 again. A's got to be 1. So my A was 1, K was 5. And so you can see that's exactly what happened. It moved up 5 places. It didn't move left or right at all, but it moved up 5. All right, let's look at B. All right, so B does have the thing in parentheses, but it doesn't have anything outside parentheses, but I can put a +0 right here, and that doesn't change anything. Okay, so what's the vertex? The vertex is at -5, 0. So that is left 5, and that's it. The A value didn't change. The A value is still 1. And so that one is different. Let's put this back to 0. All right, and the H value was, oops, that's out of my screen, but let me see. Let me move that up a little. There we go. Okay, so let's see. This one was +5. So that's minus -5. So that means H was -5. Okay. So if H is -5, okay, that's +5 in the parentheses. And so you see the vertex move to -5, 0. It's a little bit confusing, but it's just that first term that you really have to get used to looking at. So again, I just like to do the vertex first because I think it's easier to look at the vertex. Okay, so the vertex is going to be the opposite of this number, which is 3. So that means it's a right 3. So if you only look at the vertex, you can look at that and say, okay, +3, that's right 3. If you're looking at the equation itself, then you have to take the opposite. And then the X value is 6, so that's up 6. Now, this time I have an A value that's 2. So that is a vertical stretch. So if it's a whole number, and then you just say of 2. Okay? Right here, I can put a +0 there. My vertex is -4 and 0. That's left 4. And this is a reflection because I've got the negative. And you can just write reflection because it's always going to be across the X. And then vertical stretch, we'll just abbreviate, of 3. All right, so that's what transformations look like, and that's how you determine what happened to that parent function. That's really, and we do a lot of this in Math 3 also. And so there are a lot of different types of functions in Math 3 that have the whole, there we go, the whole H and K. There are, exponential functions that have H and K, square root functions have H and K, absolute value functions have H and K. So get used to seeing the H and K because you're gonna see those a lot in Math 3 when we look at different types of functions. Okay, so I'm just going to go ahead and tell you that on these are not too bad. The A value on all of these is 1. So this is a little bit easier than sometimes it would be if the A value was not 1. But all of these, the A value is 1, so we don't have to worry about that part. So since we're going to write these in vertex form, it's really easy. We just look for the vertex. Should have a pen here. So here's the vertex of this one. So I need to figure out what the coordinates of that is, and then just write it in vertex form. The vertex here is -3, -2. Okay, and if you remember, it's y equals, we have the A value of 1, so we don't have to put anything there. And then this is going to be X minus H. Okay, and this is H right here. So X minus -3 is X plus 3. And then the Y value just goes on the outside. Okay, so the vertex of this is -3, -2. All right, this one, the vertex is at, let's see, that's -2, 4. Okay, so my vertex form, what I need to realize though is this one opens down, so this is a negative on the outside. It's a -1. And then I take the opposite of the -2, X plus 2. Oh, I forgot to do my squared over here. I'm sorry. I always forget to do that part. Squared. And then plus 4. Okay, and this last one, my vertex is here. That is at 3, 1. So my vertex form is y equals, I've got X minus 3 squared and then plus 1. Okay, so that was easy. If you just find the vertex, you can write vertex form. Okay, let's talk about graphing this particular equation in vertex form. Okay, so I'm gonna, the chart, it says chart right here, but I'm gonna put it over here to have a little bit more room. We are not gonna worry about increasing and decreasing intervals. We haven't really done interval notation, so we're not gonna worry about that. That's really more of an honors topic anyway. And it's something that we do in Math 3. If I have time later, I'll go back to it. Okay, so let's talk about the transformations here. So in the parent function, my vertex starts out at 0, 0. Let's find the vertex of this thing first, and that will tell us at least where that is. Okay, so my vertex is going to be -3, -1, because it's the opposite of this, and then that number. -3, -1 is here. Okay, so the big thing about the chart is, if you remember, we talked about that over and up thing. And in a parent function parabola, from the vertex, if you go over 1, up is that x squared part, okay? So 1, 2, 3. If you go over 1, either left or right, it doesn't matter, you're going to go up whatever that number squared is. So this is going to be 1, 4, 9. All right, but the thing is, this one has a 2a value. So if you have an a value that's not 1, then you got to add one more step and multiply times that number. So I need to take this up number and multiply it times 2. So this is going to be 2, 8, 18. Okay, so I don't really pay attention to the middle part. I'm going to go over 1 and up 2 from the vertex. So I'm going to go to the right 1 and up 2. I'm also going to go back to the vertex, go to the right 1 and, to the left 1 and up 2. All right, the axis of symmetry is right here, and these things are reflected over that axis of symmetry. Okay, and then I'm going to go over 2, up 8. All right, so from the vertex, over 2, up 8 is going to be right here. And then the same thing, over 2 and up 8 is going to be on that same horizontal line. And you want to get 5 points to be able to graph it by hand. And we have 5 points. And so we don't need to do the 3 and 18. We wouldn't be able to do it anyway. So now we're just going to try to sketch this parabola. And you see it's kind of skinny. It's got that vertical stretch of 2. So it's good. And this doesn't look anything like a parabola. But anyway, good enough. All right, the domain, if you remember, the domain for parabola, all parabolas is all real numbers, and the range. Okay, so let's look for the bottom of it. Where does it cross the y-axis? It crosses the y-axis at -1, which, if you remember, also matches this number right here, the -1. So it's above that yellow line. So I'm going to have a y and a -1, and then above the yellow line is greater than or equal to. Okay, if it was down here, if it was below it, it would have been less than or equal to. All right, let's try another one. Okay, this one, we have a negative. So I know that I'm going to go, it's going to be pointing or opening down. Let's do the vertex first. The vertex is at 4, 5. Okay, so let's plot the vertex, 4, 5. And you know what? Sometimes it's easier to look at Desmos, but if you have vertex form, it's really easy just to graph the thing. All right, my chart. Okay, so this time, because I've got this negative right here, I need to multiply whatever I get right here by a -1. So it's really going to be going down. Okay, so over 1, 2, 3, that's 1, 4, 9, and then I multiply that times -1, -1, -4, -9. So I'm going to go over 1, down 1, over 1, down 1, over 1, down 1. Okay, so it's right 1, down 1, left 1, down 1. Over 2, down 4. So back to the vertex, over 2, 1, 2, 3, 4, right there. And then over 2, 1, 2, 3, 4, right there. Okay? And then just sketch that as best you can. And domain, always the same. Here the range starts right here, and it's everything below it. So that is at 5, which again matches the vertex, the y value. So we're going to have a y of 5, and this one's going to be less than or equal to. All right, and again, don't worry about the increasing and decreasing. We're not doing those. All right, last one. Okay, so this one's written a little bit different, but we can rewrite this, can't talk tonight, as y equals 3 times x plus 0 squared minus 9. That doesn't change the value of it at all. It's just that when you don't have the parentheses here, it's the plus 0. Okay, so my vertex is at 0, negative 9. Let's go ahead and plot that. 0, negative 9 is right here. And then my chart, and I'm going to multiply whatever I get for the up times 3. Okay, so 1, 2, 3, and then this is 1, 4, 9. So this is going to be 3, 12, 27. We probably won't do that last line. So I'm going to go over 1, up 3 from here. Over 1, up 1, 2, 3. This one's really skinny. Okay, and then I'm going to go over 2, up 12. 2, and then that's going to be 9, 10, 11, 12, I think. And then this is just reflected over here. You don't even have to count. All right, so let's see if we can kind of sketch this one. All right, so that's what it looks like. Increasing, decreasing, don't worry about it. Domain, all real numbers. Range starts down here at negative 9, which of course, like I told you, always matches that number. So we're gonna have a y, a negative 9, and it's everything above it, so it's greater than or equal to. All right, and that's it. And we did really well to get all that in under 30 minutes.